Hello everyone. In this lecture, we are going to cover multiplication of vector. Multiplication of vector will be of two types. First one scalar, second one vector. So scalar and vector multiplication. There are two types of multiplication. First one scalar and second one scalar product and second one vector product. Okay, so here multiplication of vector will be multiplied in two ways, scalar product or vector product. Okay, so first one we will see first scalar product. Scalar product. So a scalar product is also known as by dot product. This is dot product. Okay, so first I will take two vectors. This is two vector A and B. Both are making here angle theta. Now I have to get scalar product of vector A and B. Okay, so here first let's say vector A magnitude is A and vector B magnitude is B. Okay, and angle between theta is angle between vector A and vector B. Okay, so here theta angle between vector A and B and magnitude of A and B is this one. Okay, so here this dot product is defined as this is A dot B. That's why we call it also dot, because we are putting here dot. We always write it like this dot. Okay, so here A dot B, that is equal to A. This is defined like this: AB cos theta. AB cos theta. This is also known as B dot A, means it will be not different. B dot A is also BA cos theta. So we will get same value, AB cos theta or BA cos theta. It will be also similar. Okay, so nothing different, no changes in it. Okay, so this is A dot B is defined like this. Now this A dot B will be just a value here, AB cos theta. This will be scalar. This will be scalar. It will be not a vector. This is just a value only. That value is AB cos theta. Okay, A is magnitude of vector A, B is magnitude of vector B, theta is angle between vector A and B. So this is scalar. Here, if I'm saying theta, if theta less than 90, so here value of cos theta will be positive. Value of cos theta positive. So A dot B will be also positive, greater than 0. If I'm saying theta equal to 90, that means cos theta 0, cos 90 0. So here A dot product of two vector will be 0. If theta greater than 90, then cos theta negative. So this A dot B is also negative. Okay, so here this is scalar. It will only give a value, and if theta is changing, angle between vector is changing. So this is how we will relate here. Okay, so uh, so here we will see that many quantities are following this relation. Like if you have to get work, so we have to get a dot, means we have to do dot product of force and displacement. Okay, dot product means it will work will depend upon how much is angle between force and displacement. Okay, if angle between force and displacement is 90, work will be 0. So work we are getting according to this relation. So this is defined, two vector is defined, AB cos theta. We have to not think much about how this has come. Only A dot B is defined like this, AB cos theta, that's all, and you calculate accordingly. Okay, so here we will take an example. Like let's take here one example. If I'm saying that this is a vector 3 Newton, let's take 3 Newton. This is, let's take 4 Newton, and angle between this angle is, let's take 30, 60 degree. So find dot product. This is, let's take vector A, this is, let's take vector B. So find dot product or scalar product of both vector, of both vector. So how will we solve it? This is very simple. Dot product means we have to find out A dot B. This will be defined as AB cos theta. So A is 3, B is 4 cos 60. This value is 4 into, this is 3 into 4 into 1 by 2. This is 2. So I'm getting here 6 Newton. So dot product is, I'm getting here, this is 6. Okay, so here this is 6 unit. Okay, so this is how I'm getting dot product. Okay, let's take another example, or let me in general form note. Let's take here a vector A is written like this, 3D form, x I cap, a y, j cap, a z, k cap. Okay, another vector B is written like this, b x I cap, by, j cap, bz, k cap. So if I want to find out dot product, so here how dot product will be. If I will multiply I and j, it will be 0. I and k 0. Only I and I will be 1. So here we will get ax, bx. This will be ay, by. This will be az, bz. So I will get dot product of two vector like this. Okay, so two vector is given in Cartesian form. Then how we will get dot product? We will get dot product like this. So here one more question. Let's take here a vector A is given, in general 1 I cap, 3 j cap plus 2 k cap. I'm saying vector B is given here, 2 I cap minus 2 j cap plus 3 k cap. So find dot product. Dot product means find A cross B. Okay, so to find out A dot B, what will I do here? Simply A dot B. So A dot B is, we know that this is only this coefficient will be multiplied. Why? Because if you multiply this one with this one, I dot j 0, I dot k 0. Why? Okay, so I'm explaining why this will be 0. If I'm saying that, if I'm saying that here, let's take a axis here. This is x axis, this is y axis, this is z axis. Okay, so here along x I cap, along y j cap, along z k cap. So I'm taking here three unit vector along x, y, z, I cap, j cap, k cap. So if I'm calculating here dot product, so I dot I will be equal to 1 into 1 into cos 0, it will be 1. Similarly, j dot j will be equal to 1 into 1 into cos 0, that is also 1. K dot k will be 1 into 1 into cos 0, this is also 1. But if I am taking I dot j, so it will be 1 into 1 into cos 90, it will be 0. Similarly, I will get here any two mutual perpendicular unit vector I will take, so dot product will be 0. So if I am taking here j, k, this will be also 1 into 1 into cos 90, 0. K dot I, this will be also 1 into 1 into cos 90, that is equal to 0. Okay, so here any two unit vector you are taking which is perpendicular to each other, so dot product will be 0. So exactly if I will multiply here with each one, so I will be 1 but ij 0, ik 0, exactly ji 0, jj 1, jk 0. So only we will get this one, this product we will get here. So 2 into 1, this is 2, and this is minus 6, this is 6, so I will get here 2. Okay, so dot product of two vector is 2 here. So only we have to multiply here coefficient of I cap, coefficient of j cap, coefficient of k cap, and this is scalar, so it will be a value only, we will get a value only, no vector. Okay, so here This is how we'll solve. One more question we'll take here. Let's take find the work done. Find work done in displacing a particle from 1 2 3 to 4 5 6 using force force F using force F equal to, let's take here 2 I cap plus 3 j cap plus 2 k cap. Okay, so this is the force I'm applying on a particle, and due to this force I'm able to shift the particle position from this to this. Okay, so here we know that work equal to, if particle is shifted from this point to this point. Okay, so this is shifting. This is initial point 1 2 3, this is final point 4 5 6, and force you are applying this one. Okay, so here what is work done? Work done is dot product of force into displacement. This is displacement vector. Okay, so here how much force you are applying? 2 I cap plus 3 j cap plus 2 k cap. How much this displacement vector? Displacement vector we will write here. Displacement vector means final position minus initial position. Okay, so here 4 minus 1, this is 4 minus 1, 3 I cap, 5 minus 2, 3 the j cap, 5 minus 2, 6 minus 3, again 3 k cap. So this is displacement vector. So work we have to get. So dot product, we know dot product only coefficient will be multiplied. Okay, so coefficient here is 2, here 3, so it will be 3 into 2 6 plus 3 into 3 9 plus 2 into 3 6. So this is 6 6 12 plus 9, this is 21, and this is if this is meter, this is Newton, so it will be joule. Okay, so this is how we will get. Okay, or this is joule. Okay, so this is how dot product is. Dot product or a scalar product is only a magnitude. Okay, and that magnitude is AB cos theta. Okay, this is dependency upon angle. Okay, Cartesian form. If unit vector is given in x, y, z, so we will get here dot product 1, dot product 0. Okay, so this is all about scalar product. Next one is vector product. So for vector product, second one, vector product. Okay, so in similar way, this is a, let's take a vector A and this is vector B. So this vector A and B is angle between vector A and B is theta. So we have to define here dot cross product. This is also known as cross product. This is cross product. So here A cross A, this is cross, that's why we call it also cross. So cross product A cross B, this is defined as A B sine theta and one unit vector. This is a vector quantity, unit vector. Okay, so A cross B is AB sine theta into n, where theta is angle between A and B. A and B is magnitude of vector A and vector B. Okay, this is unit vector, which is, okay, this is unit vector unit vector perpendicular to plane of vector A and B. Vector A and B are perpendicular to a plane containing A and B. Okay, so this is just a unit vector which is perpendicular to plane containing A and B. Okay, we can also write this n cap will be perpendicular to vector A and vector B. Perpendicular to A and B both, or we can say perpendicular to the plane of A and B. Okay, This is just a unit vector. Okay, so this will give only direction. If you want to find out direction, so if there is plane, like let's take this is a vector a, this is vector b, two vector. Okay, so this will constitute one plane, this is a plane. Now this direction is perpendicular to this plane, but this direction is also perpendicular to this plane. So I am getting here two direction, one above perpendicular, second below perpendicular. So here we will use right hand thumb rule, right hand thumb rule, thumb rule to find direction, to find direction. What is right hand thumb rule? If there is a cross b, so you curl your forefinger from a towards b, from a towards b. Direction of thumb will represent direction of n cap. So this is here. So if this is, you are moving like this, curl your forefinger from a to b, so this out of plane. Okay, this is z axis, this is z axis, out of plane means out of plane. I can also write by dot. This direction also represents dot. Dot means out of the plane, cross means into the plane. So this will come later on. Okay, so don't confuse here. So this is a cross b is up, means out of plane. B cross a, if I'm writing b cross a, so this value will be again same but opposite to this one. So this will be minus a cross b. Okay, so here b cross a will be in value ba sin theta. So we will get same value but direction will be opposite. So this represents here direction opposite of, this is representing direction opposite of a cross b. Okay, so whatever is direction of a cross b minus a cross b means opposite direction. So b cross a will be nothing but only minus a cross b. So this is how cross product is defined. Okay, unit vector perpendicular to the plane containing a and b. This will be also perpendicular to a and b. Like this is unit vector, dot dot means like this. So this is one vector, this is another vector. Both a and b vector is in a plane of this whiteboard, and this perpendicular direction representing here direction of a cross b means a cross b. This one. If b cross a, so b cross a. So b cross, curl your forefinger from b towards a. So it will be into the plane. So into the plane will be b cross a. If a cross b out of plane like this, so b cross a will be into the plane. Okay, so this is how vector product is defined. Okay, so here if two vector are given like this, okay, let's take here two vector given like this. Two vector given, let me calculate first for Cartesian first, then I will come to, this is Cartesian for our x y z. So I am saying unit vector along this is I cap, unit vector along y is j cap, unit vector along z is k cap. So if I want to find out here I cross j, so what is angle between it? 1 sine, this is of course 90, so this will be 1. Similarly j cross I, this is I cross S. If I am calculating j cross I cap, so it will be, again here we have to put direction also. So I cross j, so I cross j, it will be k cap. So this will be k cap. Okay, means unit vector, but this unit vector will be k cap. Okay, so here if I'm calculating j cross I, so it will be again j cross I, so j cross I will be negative k cap. So this will be 1 into sin 90 into negative k cap. So this value will be negative k cap. This value will be overall k cap. So I cross j cross I, if I'm calculating j cross k, so j cross k. So this j cross k means j cross k. If I curl my finger from j cross a, so direction of thumb will be along x. So this will be 1 into sine 90 into n cap. N cap will be x here. So it will be only I cap. Okay, so j cross k Similarly, k cross j, if I'm writing, it will be negative I cap. Okay, so ij, jk, if I'm writing k cross I, so this will be 1 into 1 into sine 90, and k cross I. So k cross I, this is k, this is k. So if I curl my finger k cross I, it will be towards y. So this will be towards y. Okay, so this is j cap only. So I cross k, this will be minus j cap. Okay, so this is how, if I'm taking cross product of same vector, same unit vector, then I cross I will be 1 into 1 into sine 0, it will be n cap sine 0 0. Similarly, j cross j, so cross product of similar unit vector will be 0, so this will be also 1 into 1 into sine 0 n cap, this will be 0. K cross k, this will be also 1 into 1 into sine 0 n cap, this will be also 0. So cross product of similar unit vector will be 0. Okay, cross product of two mutual perpendicular unit vector is always 1, only we will take care direction. Okay, so this is how we will calculate. So for direction, better we will remember one rule. Okay, that rule is, you draw a circle and you write here, this is I, here you write j, and here you write k. So better you remember this one. If you will move here clockwise, you take positive, and if you move here anti-clockwise, so you take here negative. What is the meaning of this one? If you are moving here clockwise, means I cross j, so next one is k cap and positive, so I cross j equal to k cap, I cross j k cap. Next one, j cross k, next one I, so j cross k cap, that is equal to I, k cross I, k cap cross I, that is equal to j cap. Okay, if you are moving opposite like this, like you are saying k cross k cross k cross j, so opposite you are moving anti-clockwise, so k cross j will be minus I. Similarly, j cross I, you can write j cross I equal to k cap. You can write I cross k equal to minus j cap. Okay, so this is how we will take. So better you remember this one, a circle ijk, clockwise ijk, jki, kij. So clockwise positive and anti-clockwise negative. Okay, so we can use this concept here. Okay, so next we'll find out cross product of Cartesian form, cross product of two vector, 3D vector. Okay, so this one we will complete it. So next So here I will take two vector in 3D form. This is vector A equal to AX I cap, AY J cap, AZ K cap. Another vector B I will take BX I cap, BY J cap, BZ K cap. Now this is very important. Okay, this is A vector and B vector. I want to find out A cross B. So this is A cross B. So A cross B. So A cross B, you can find out this one. You multiply with this one, this one, this one. Again, second part, second term, you multiply with first term, second term, third term. This one multiply with this term, this term, this term. So we will get here 9 terms. Okay, 3, 3, 3, and that will be lengthy. So we have developed here a technique to solve cross product of two vector. We will write here I, j, k cap. So first vector ax and ay, this is az. Second bx, by and bz. Okay, so here we can write I. When you are picking here I, okay, then you have to multiply here this one cross. Okay, so I, you multiply this one, so this is ay bz minus az by. Clear? I you are writing, so ay bz minus by az. When you are writing second, so we have to take here negative, positive, negative, positive. So again, when you are writing j cap we have written, so skip this one, skip this line, skip this line. So this 4 is left. So again here ax bz minus az bh. Clear? This one and this one. Okay. Next, if you are writing k cap, so you skip this one. So this 4 left. So ax, this is ax by minus ay bx. Clear? Ay bx. So this is how we'll write cross product, and of course this is vector form. So vector form I'm getting here. So this is very important conclusion, but better you do not remember this type equation, you remember this kind of determinant form. Okay, so you write here x I j, this I j k, and you just take cross product, then when you are writing this, then cross product. Okay, so ax by minus bx ay. Clear? So now based on it we'll take few example. Okay, so two example we'll take here. So let's take here a vector a is 2i cap plus 3j cap plus 5k cap. Okay, another vector b I'm saying 1i cap minus 2j cap plus 3k cap. So find first find first magnitude a, second magnitude b, third you find out dot product, and fourth you find out cross product. Okay, so here we can solve it an angle between vector a and b also, theta also. Okay, so here we can calculate it. Let's take first one vector a mod, that is a. So this value will be, of course, this is 2a square, 3a square, 5a square. This value will be 4 plus 339 plus 25. This value will be, and this is 9 4 9 4 13 13 25. This is 38. So root 38. If you are calculating vector v, so vector b will be b, that is equal to, you can calculate here, vector b is 1 plus 4. This is 1 square, 2 square plus 9. This value will be under root 14. Okay, so a, b. If you are calculating dot product, so dot product means only you have to take coefficient. So this will be 2, this 2 minus 6, 2 minus 6 plus 15. So this will be, this is 2, this is minus 6, this is 15. Okay, so this is minus 4 plus this is 15, this is 11. Okay, so third part, this is first part, second part, third part. If you want to find out angle, let me find out first angle. So you know that a dot b equal to ab cos theta. So we can write here cos theta equal to a dot b is 11 we have got, and a is root 38. This is root 14. So we can calculate this. Don't need to calculate. This is cos inverse. This is 11 upon root 38 into 14. Okay, so just method I'm telling, I'm not going to calculate exactly. Now cross product. How will I calculate cross product? So to calculate cross product, we will write here, this is A cross B, fourth one. So A cross B will be equal to, we will write here like this. This is I, J, K. What is I? Coefficient 2, 3, 5. This is 1, minus 2, 3. So if I am calculating here, so I will get here answer I. This is 3 into 3, 9. This is minus 5 into minus 2, minus 10. So this is minus 10. Okay. So minus j cap. This is 3 into 2, 6. Minus 5 into 1, 5. Plus k cap. K cap, this is 2 into 2, minus 4. 2 into 2 minus 4, minus 3. So finally I am getting here, this is plus, so this is 19 into I cap. This is 6 minus 5, 1, 1. So it is simply j cap. This is minus 7, k cap. So this is a vector, I am getting here vector. So A cross B is 19 I cap minus j cap minus 7 k cap. So if any vector is given in this form, we can calculate magnitude. We can calculate angle between vector A and B using this concept. A dot B equal to AB cos theta. This one we can calculate easily. AB we can calculate. So cos theta we will get. Then theta we can get. Cross product is we will calculate like this. Okay. So this is how we have to solve question. Okay. Okay, so that much is enough. Okay, so overall this basic mathematics part is now over. Okay, everything we have completed. Okay, in vector this one is last topic, vector product. So scalar product, vector product is also over. Okay, so you practice more and more question. Okay, so I'm closing it. Okay, thank you so much.